Hello and welcome back. Now we're going to finally go over the 12B AME cutoff predictions. So let's get into it. So following a similar system as I did on the previous three videos for these predictions, I'm just going to look at the front end of the test and focus on it the most, since that's really what drives the cutoffs up or down depending on the difficulty of that section. So if you guys saw the 10A, 10B video, one funny thing we can notice is that the first five is actually just identical. So that's kind of hilarious. But it has a similar assessment, which is that these problems are easy, but also really hard to silly. So the sillyableness is really low. So that drives the cutoffs up since less people make mistakes on it. So there's a lot of routine stuff in the first 10. However, one thing to notice is that problem 10 is a pretty difficult problem. So this can actually time sink people thinking that, oh shoot, I'm doing the test and I saw, oh, problem 10, but I'm not able to solve it. So now my confidence is broken for the entire test. So although that could happen to a fair bit of people, this is really I'd say a turning point of the test, since this problem gets sillied a lot. So that can actually drive the cutoff down. So I think after the turning point, the general audience vying for the AME call would probably only make it as far as problem 16 I'd say, in terms of the scope of problems they really covered well. So I'll look at those. So problem 11, it's routine. Normally when you achieve a sum like this, you would pair it. So I don't think 11 was too difficult. 12 also conceptual understanding, you can do it. Now one thing which stands out to me about 13 through 15 is that when solving these problems, the solution really just comes to you. There's not much you can do to oh, I didn't find the solution. It's really the approach which is the most obvious is actually the most ideal solution, which is what makes these problems much easier. For example, problem 13, that reminds me a lot about conic sections. So I tried completing a square, and turns out that's how we minimize it. Now number 14, this is a direct application of a theorem, Euler-Stoichern theorem. So if you're doing some last minute review before the test, you'd probably get 3 points on this question. Number 15, it gives you a bunch of ugly coordinates. So you think, I have the coordinates, I can just shoelace this. Use the shoelace formula, since it's a pretty common formula, and this is the opportune setup for it. And then after you do it, you just do log properties. Number 16 also is a typical multiplication principle problem. So really what I'd see from the thing is that although the first 10 might have some hitches in terms of 10 throwing many people off, really 1 through 16 was actually pretty doable with some amount of training beforehand. So now you might think, okay, if the audience was capped through 16, that must make the cutoffs really low. But the thing is that after you get burned out from doing the first 15, you might be scrambling in the back to see if you can get any solves. For the audience, I don't think anything above 19 was really there, 3 points. The closest thing I can think about is problem 21, but that's still slightly harder to see. But one thing which really does look really easy for some people is just this problem 18, which is, can you just take the sum of these? So if you're willing to invest a few minutes into it, you can actually get the answer out of it. So really my general assessment is that the mid-range was actually easier than the 12A, and I think that disparity between the 12A and the 12B was actually large enough to drive up the cutoffs a similar amount as I placed the 10A and the 10B. If you recall, I predicted the cutoffs for the 12A was 81, a really hard test, rock bottom. But honestly, I think due to the routineness and the straightforwardness of some of these problems, and also some chip problems like problem 18, I think the cutoff is going to actually go up to a number 88.5. So that's going to be my guess. But remember, don't take this too seriously, just a prediction. We'll see when the actual things come out. But thank you for watching this video. If you like this content, remember to subscribe and like, and I'll see you next time.